Yes, good evening all. Is this audible?
Yes, ma'am.
All right. Oh, all right, Fahad, just take the lecture. Take the recording of the lecture. Every lecture gets recorded. So you can take the last lecture. All right. What did we discuss? We studied a relation between electric field and potential and equipotential surfaces. These two topics were covered. So today is the last class for potential portion. Then we have to start with capacitance. Are you people available on this coming Sunday? Because most of you must be having your summer vacations going on, no? So if you people are available on this coming Sunday, we can have a 2-hour class on capacitance. So major portions of capacitance can end and we can start with current electricity. So just text me if you people are available or unavailable. Then accordingly, I'll plan the lecture. So you can write me in the chat box, all of you. All right, so last topic that is left in potential is potential energy. Timings according to you, I can set. I am available on Sunday, so I can set the timings according to your needs. You people have this class at 6:30, no? Your timing is 6:30 right now. If you're available on 6:30, I'm fine with it. Otherwise, you can have a class from 6 to 8. 2-hour class would be required because you people also know, no? At least in your during the course of your vacations. During the course of your vacations, at least you can have the extra classes. Otherwise, what will happen? You will be having maths class. It's from 6 to 8. Okay, other timings, Fahad? If it's from 6 to 8, then can we have a class from 4 o'clock? Okay, Rifat has what? You have classes from 4 to 7:30. On Learnivio. Is it on Learnivio? 4 to 7:30. Okay, okay. You people have your maths class 4 to 7:30. Fine, I'll check. I'll check with your classes. All of you are there on the WhatsApp group. No, I'll update. Yes, Samia, how are you?
Good, ma'am.
Your exams were going on because after a long time you have joined the class.
Yes, ma'am. Exams are done.
So now they are completed.
Yes, ma'am. Completed.
So summer vacations have started, Samia.
Yes, ma'am. From today it started.
Today it has started. All right, all right. And what about Saturday? Saturday also you people must be having your classes, no? On Learnivio, Fahad and Rifat. So only Fahad and Rifat have joined. 4 to 7:30 is your which class, Rifat? Maths class. Chemistry and maths class. Okay, so you're complete, that is blocked. So if you people say we can have a class in the morning on Monday as well. Because you people, if you don't have your classes on Monday, we can have a class on Monday in the morning timings. Any time that is comfortable to you on Monday even. So just keep on suggesting the time according to you, then we'll discuss. If nobody has issues, we can fix up that time. Because this is the time only which I can take your extra classes in the morning time because of your extra classes. See, capacitance need 2 classes at least, 2 big classes minimum. So at least we can have 2-hour classes. 2 classes we can have for 2 hours. So 4 hours will complete our capacitance so that we can straight away move on to current electricity. So all of you just keep on suggesting me the timings, whatever is suitable for you, the day with the timing, we'll discuss it. If it's fine for everyone, we can have it. Even on Monday, if you're available on 11 o'clock or any timing. Because Friday is obviously a busy day for all of us. So Friday, definitely you can have your holiday. Come next Friday, we can arrange classes. But Monday, if you people are available on 11 o'clock or such timing, KSA timing, your timings. So just let me know. Okay, suggest me that we can discuss it. Now, potential energy. Let's quickly discuss potential energy. See, potential energy, before starting with potential energy, let me tell you, energies are of many types. You must have already heard of. Kinetic energies you have heard of, potential energy you have heard of. So reason behind kinetic energy is what? any motion which occurs that causes your change in kinetic energy that we calculate. Now, what is the cause of potential energy that we are calculating? Basically, cause of potential energy is the interaction that I have written, electrostatic interaction. Now, what is meant by this electrostatic interaction? Electrostatic interaction basically means exertion of force on each other. For example, if I say there are two charges, let's say there are two charges, Q1 and Q2. Both these charges are present. Now, Q1 will exert force on Q2. Q2 will also exert force on Q1. It means both of these charges, what will happen? They will exert force on each other. They will interact among themselves. That is known as electrostatic interaction. That causes your potential energy. For example, if I have only this charge Q2 and no other charge, then there won't be any other charge to interact with, no other charge to exert force on. So potential energy will simply be zero. Right now there are two charges, so both the charges can exert force on each other. If both the charges exert forces on each other, they have electrostatic interaction among themselves. See, this can be cleared by this through. If I bring a third charge, Q3, Wafia, if at any point you're not able to understand, just ask me, I'll repeat it because you have joined from the last class only, no? So if you have any doubts, Wafia, you can ask. All right.
Okay.
So let's say I have brought a third charge. Now what will happen? You can see Q1 and Q2 both are exerting force on each other. Q2 and Q3 will also exert force on each other. Q1 and Q3, both of them will also exert force on each other. It means there will be three interactions. We can easily count. 1, 2, 3. Three interactions, so three potential energies. That is the ultimate cause of potential energy. In lower classes, we have read that change in motion brings up kinetic energy and change in position, shape or configuration brings us change in potential energy. That's not the only cause. For potential energy, you must have electrostatic interaction. If you see, not only charges, this is valid only for, I am teaching only because of current and charges. If there are two masses kept, m mass, two masses are kept, then also both the masses will exert potential energy on each other. Why? Because they will exert force on each other. Wherever you see forces that are getting exerted, you call it as an interaction. So in case of gravitation, we deal with gravitational force. Gravitational forces exert and cause the gravitational potential energy. Here, in case of electrostatics, we are dealing with charges. That's why I'm only focusing on charge. So in case of electrostatics, we are dealing with only charges. So charges will have electrostatic force according to Coulomb's law that we have studied in initial lectures only in the last chapter. They will exert Coulomb's force, and these Coulombic forces, both of these will exert electrostatic interaction as they will exert potential energy. So potential energies are also of many types: gravitational potential energy, electrostatic potential energy. Right now you have to deal with potential energy. Now, whatever is this concept of interaction and how to deal with it, that you will be able to understand through the help of questions and as we proceed towards the derivation. One formula that you people should know. If you're not aware of this formula, work done is given by charge multiplied by the change in potential. This formula is utilized a lot in the derivation of this. Now see. So basically, what is potential energy? Let me show you. If I have, let's represent it with the help of graph. This will become easier. This is the y-axis, this is the x-axis. Supposedly there are many charges, or let's only take two charges. Let's take two charges. Two charges are kept at infinity. Now, I have brought the first charge from infinity to a particular point. Let's say A is that particular point. So from infinity, I am bringing up this charge to this point A. Now, whatever will be the work done in bringing this charge from infinity to this specific point A, that is known as the work done. This is the definition of work done. Work done is what? Work done is basically the energy to assemble the system. We are assembling a system. From where? From infinity to a particular point that we have taken. So supposedly I have brought Q1. Now, is there any other charge to interact with? Do you see any
No.
charge present? No, right now there is not a single charge present. It means work done to carry this charge from infinity to this particular point A. It will simply be zero. What did I tell you? Energy is work done. Work done is a form of potential energy. All the work done gets stored in the form of potential energy. So if there is no interaction, it means there won't be any work done. So simply work done in carrying this first charge will be simply zero. Work done 1 means work done. Let me write down this. Work done in carrying charge. Q2 is not there. Q2 we haven't brought. Q2 is still at infinity. All right. Right now only Q1 is there in the system. This is our system, the graph that I have drawn. That's why I've drawn the graph. So I have to specify the system. So Q2 is there at infinity. Right now we haven't brought. So work done in carrying charge Q1 from infinity to this point A. This is 0. Now, let's say this separation is what? This separation is R1. Fine. Now, the second charge I am bringing from infinity, I am bringing up this charge. Let's say this is some B point. I have brought this charge Q2 and the distance is the relative separation between both of these charges Q1 and Q2. I am taking it as R12 because when you read no R12, it tells you that this is the separation between 1 and 2, charge 1 and 2. All right, so work done in carrying Q1 was 0. Now Q2 has been brought. Now tell me, will the work done be still 0 or it will be having some work done?
It will have some work done.
It will have some work done. Reason? Because there is an interaction now present. This interaction is still there existing. It means now we will have a potential energy. So can you see this complete work done to make this system? That let's see at the end only. So work done 2 will be what? Now, charge, what formula I told you, especially for you, Wafia. This formula we have discussed earlier. So, the older students must be knowing this. Charge multiplied by the change in potential. This is the formula of work done. Now, what is our charge? Charge is Q2. So, work done will be what? Work done will be simply Q2 multiplied by the change in potential. Final potential minus initial potential is the change. Now, final potential is being generated by what? Who is interacting with Q2? Which charge is interacting with Q2? Yes, class, see?
Q1.
Q1, exactly. Q1 is interacting. It means Q2 is actually in the potential of Q1. Whatever is the potential of Q1, there we have the charge Q2. That's why no, they are able to exert force and on each other and we are able to observe this interaction. So potential will be, final potential is VB, not VB, VA. Potential generated at charge Q1. This is VA minus initial potential. Where was our charge initially? At infinity. So this will be V infinity. Now, remember, potential at infinity is always 0. Always remember this. Potential at infinity is taken as 0. Fahad, can you tell me if charge is Q1, separation is R12, what will be the potential VA? K Q1 by R12. Perfect, Fahad. Very nice. Charge is, this is the general formula of potential, KQ by R. So K is a constant. Q here is Q1, R here is R12. Now let's put it, all the values. V infinity will simply be 0. Work done 2 will be what? K Q1 Q2 divided by R12. This is how do we write the work done. Now, what is the total work done? Total work done basically, this is W1 plus W2. W1 plus 0. W1 was 0. W2 is KQ1 Q2 by R12. So complete work done becomes KQ1 Q2 divided by R12. Now, the total work done, whatever is the total work done to assemble this system. Assembling of system means carrying the charges from infinity to a particular point that we have chosen. All this work done gets stored in the form of potential energy. So this is the formula of potential energy as well. This is the whole concept of potential energy. I think I have written the definition earlier. Yes, electric potential energy is the work done by the external force in carrying charges from infinity to their respective positions. All right, this is the concept of potential energy. W1 part, how it became 0. Yes, Fahad. See, we are assembling the system. We are initially bringing up this charge Q1 from infinity. Firstly, when we brought this charge Q1 from infinity, there was no other charge to interact with. This was the first charge. No, it's like the first human, when the human being was there, first human was there. There wasn't any other human being to interact with. Similar is the case. From infinity, Q1 is there. No other charge to interact with. So no interaction is there, no potential energy is there, no work done is there. Now, when second charge has been brought, then we are able to observe all these calculations. Clear, Fahad? Is this clear? Okay. So you people noted down. This we have studied for 2-point charges also we have discussed. If the derivation comes in your exam, write down the potential energy or for system of 2-point charges, then that derivation you would write. But if it comes potential energy for n number of system, n number of point charges, that we'll discuss. First note it down, then we'll discuss it. Kafia, do you also take classes on Sunday? Do you also have any class on Sunday?
Yeah, ma'am. Sunday I have biology.
Okay, okay, all right. Written. Shall we move forward?
Yes, ma'am.
Uh, okay, so if n number of point charges are there in your system, this is the main thing you have to remember. This is also easy. It's just that one trick you people should be able to identify. With the help of that trick only, that's not a difficult trick, it's just a formula only. With the help of that only, Q2 is multiplying. Q2 is getting multiplied where? Here. This part. Are you asking this? Why is Q2 over here? See, what is the formula of work done? Work done says charge multiplied by change in potential. Which charge are we bringing now? We are bringing Q2. And then what is the change in potential? Change in potential is this. Clear? That's why Q2 is there. So V multiplied by Q gives the work done. Okay. So what were we discussing? All right. Yeah, I was telling you the questions that come in your exam, no, regarding potential energies and different systems. With the help of this only, that will be clear. We'll see examples as well. Let me put the graph so that it defines your system. We are bringing charges in this system. So that helps us in deciding infinity. Let's say Q1, Q2, Q3, Q4, Q5, Qn, n number of charges are present in infinity. First, I have brought charge Q1. Now, can you tell me what is the work done here?
0.
0. Good, Samya. It will be 0. Work done 1, W1 will be 0 because see, now you people can see there is not a single charge in our system to interact with. So let's say this separation, this is R1, this is 0. Now Q2 has been brought. Separation between both of these is what? R12. So W2 is what? That we have seen previously. It is K Q1 Q2 divided by R12. Always remember this is the general formula. K Q1 Q2 divided by R. This is the formula of your potential energy. All right. Now the third charge Q3 has been brought. Now see, it has a separation from Q2. Let's name it as R23. If we name it as R23, that will tell us it's the separation from 2 and 3. Separation between 2 and 3. R23 is the separation between Q2 and Q3. Also, Q3 will be interacting with Q1 as well. So let's say the separation between both these, Q1 and Q3. This is R13. By just looking at these, no, R13, R23, you will be able to identify which separation is this. Means what is the separation between which two charges are involved in this separation. Now, Q3 is there, Q1 is there. R13 is a separation, Q2 is there, Q3 is there, and R23 is a separation. Now, understand here only how to write this. This will help you solve all of your questions. Work done 3. The general formula in this, the general formula here, this is K Q1 Q2 divided by R. Remember, this is the formula of work done or potential energy. Right now, we are focusing on work done. So between Q1 and Q3, first Q3 is interacting with which charge? Q1. So it will be K Q1 Q3 divided by the separation between Q1 and Q3. That is R13. This is the work done between Q1 and Q3. Now Q3 is interacting with also Q2. So you will be having Q1, you will be having one energy between Q2 and Q3. So it will be K Q2 Q3 divided by their separation, and their separation is R23. First, tell me, all of you, is this writing portion clear? If this is clear, then only you will be able to understand further and solve all the questions of potential energy.
Yes, ma'am.
Yes, ma'am.
Clear? All right. Wafia, is it clear to you? Rifat?
Yes.
Okay. All right. Now see. Let's say the separation must have been R3. This was R2. Okay. Now let's say Q4 has been brought. Q4 has been brought from infinity. Now look at all the charges that are already present. Q1 is there, Q2 is there, Q3 is already there in our system. Now we have brought Q4. Separation between 1 and 4, it will be R14. Separation between Q2 and Q4, this will be R24. Separation between Q3 and Q4, this will be R34. That's how we name them. All right, now we have to write all the potential energies. So work done 4. General formula, I'm reminding you people, K Q1 Q2 divided by R means first charge, second charge divided by the separation between the charges. Now you people try it yourself. Wafia, can we start with you? This is the general formula. First, tell me the potential energy between Q1 and Q4. Just put it in this formula. Just try.
K into
K
Q1
to Q1
into Q4
Q4 divided by
R14.
R14. Perfect. Very nice. This is how we have solved it for this. Reem, try it for the second one with Q2.
Map Q1 and Q2.
Yes, Q1, Q2. Q2 and Q4. This interaction. Second interaction. Try.
K,
K
Q2,
Q2
Q4
Q4.
by R24.
Very nice. Bit by R24. Samya, can you try the last one?
K Q3 Q4 upon R34.
Yes, excellent. R34. This is how we write the total work done. Now, had there been Q5, let's say Q5 was also there, then one more potential energy would have been added. Q5 with Q4 divided by R45, like this. If Q5 is there, first calculate Q1 Q5 divided by R15, Q2 Q5 R25. Like this, you have to solve it. All right. If n number of charges are given, just keep solving this way. Now, what is the work done? Total work done will be what? Work done will actually be W1 plus W2 plus W3 plus W4 and so. And this total work done is equal to the potential energy. So let's even write it. Potential energy of this specific system is, firstly it is 0, W1 is 0, W2 is K Q1 Q2 by R12. Then W3, this came out to be K Q1 Q3 by R13 plus K Q2 Q3 by R23. Then the last one which we all discussed right now, that was K Q1 Q4 by R14 plus K Q2 Q4 by R24 plus K Q3 Q4 by R34. This is how you calculate the potential energies. Now, note it down. We'll do questions on it. Then only this will get clear. When you'll see the actual values, know how to put it. We'll do numericals on it. 2 numericals at least we'll do right now. First, note it down. Any step you are getting stuck, text me in the chat box. Unmute yourself. Ask me whatever is suitable for you. But do ask, because with this concept only, you will be able to solve all the numericals. We'll do numericals right now only. So is 11 a.m. fine for you people on Monday? If anybody has issues with it, just text me for starting with capacitance, because in today's class we'll be able to finish potential, but we need extra classes, no, in your summer, during your summer vacation. So just text me if you have any issues with it. If you're done with it, then fine. Yes, KSA timings, your timings, not mine. KSA timings. 11 a.m. it's fine for you people?
Yes, ma'am.
All right, then we can have a class on Monday at 11 p.m. Yes, Fahad, totally based on this. Firstly, we'll do two numericals we'll do. First one we'll do 2-point charges based, and second one we'll do like this whole system. Let me write down the question for you people first. See, two charges are given, 1 and 2, both these charges are given, separation between them is given. At least all of you can find the answer of the first part. Then second part and third part I'll help you, but at least try to find out the answer of the first part. And always remember, in case of potential energy, we do not take the magnitude, we take the sign as well. So try to answer the first part. This is the potential energy between 2-point charges. Try, see whatever you people are getting your answers, send me in the chat box, then we'll discuss it. And I'll help you with the then second and third part. I'll tell you fast. When we reach the third part, no, I'll tell you what is meant by bounded and bounded. Firstly, you people try the first part. Then I'll help you with the second and third one. I'll explain. Samir, try again. Some error in your calculation is there. Have you converted every unit? Milli into SI unit, micro into SI unit. Just check once again your calculations. Others also respond. Yes, Fahad, this is the formula in which you have to substitute all the values. But before substituting, just ensure that you have converted everything into SI unit. You people are aware of the SI units of length and charges. See, formula is that only. Fahad has correctly written it. It is K Q1 Q2 divided by R, means the separation. Q1 is what? Q1 is 2 millicoulombs. And how do we convert millicoulombs? We multiply it by 10 to the power minus 3. Wherever you get the symbol milli, no, just convert it into 10 to the power minus 3 coulombs. Q2 is what? Q2 is minus 3 microcoulombs. So this will be minus 3 into 10 to the power minus 6 coulombs. All right, micro is 10 to the power minus 6. Milli is 10 to the power minus 3. R is what? R is 3 millimeters. So this becomes 3 into 10 to the power minus 3 meters. Now we just have to put in all the values. K, if anyone has forgotten, K is 9 into 10 to the power 9. So just substitute this. Potential energy becomes 9 into 10 to the power 9. K. Q1 is 2 into 10 to the power minus 3. Q2 is minus 3 into 10 to the power minus 6 divided by R is 3 into 10 to the power minus 3. 3 gets cancelled. 9 into 2 is 18 with this negative sign. Minus 18 into minus 3 gets cancelled, and 9 minus 6 is 3. 10 to the power 3 joules. This is your potential energy. Now, second part says work done to make the system. See, work done to make the system is what? What did I tell you the definition of potential energy? Potential energy is only this, no? The work done to make the system. So it's asking you what is potential energy again actually. In this is the answer of the first part. No, the second part is work done to make the system. This is potential energy only. That will be equal to minus 18 into 10 to the power 3 joules. Remember, had the question been work done to break the system, then you would have taken minus of it. Means minus, that would have been plus 18 into 10 to the power 3. Work done to make the system is negative of work done to break the system. Remember this point. So potential energy, it is actually asking you the potential energy only, work done to make the system. Third part says bounded or unbounded. No, that you were asking also, Fahad was asking. See, whenever you have a negative potential energies can be of two types. You can get a negative potential energy, you can get a positive potential energy. Negative potential energy shows that system is bounded. System is bounded. This shows that system is bounded. And positive shows that system is unbounded. Bounded. Now, what is the meaning of this bounded and unbounded? See, bounded system means that your system is stable. Potential energy is high, potential energy is negative, system is bounded, your system is stable, in stable equilibrium. Positive potential energy represents unstable equilibrium. Your system is disturbed, unbounded system is present. That is meant by bounded and unbounded. Equilibrium, it basically represents the state of equilibrium. So that's how we choose. So easily we can identify potential energy is coming negative, so it means our system is bounded. So this will be the answer. Yeah, that's how we solve these questions. Now this was based on only 2 charges. Then let's do one numerical on multiple charges as well. First note down this, all those who were not able to do it, and check your mistakes where you got stuck. Samya, calculation error.
Yes, ma'am. I forgot to put the value of k.
All right. Okay, that's why you were getting in terms of -2. Okay, fine. Second part is what? Work done to make the system. See, the definition of potential energy. What was the definition of potential energy that I told you? All the work done to make the system. Means firstly, it might have happened that 2 millicoulomb was brought from infinity, then -3 microcoulomb was brought from infinity. So all the work done to make the system, that gets stored in the form of potential energy. This is the definition of potential energy as well. So the second part says work done to make the system. It means it is directly asking you to calculate the potential energy, because we people are aware that work done to make the system. Making of the system means what? Making means bringing charges from infinity to these particular respective points which are given right now. So all the work done to make the system is basically potential energy of the system. That's why we have just equated it directly to the formula that we have calculated. Now clear? All right, class, can you tell me what is by looking at the figure, can you tell me what is the a number of potential energies possible? See, 4 charges are present at the vertices of a square with side A. You have to calculate the potential energy of the system. We have seen if we have more than 2 charges, we have to count the interactions. So according to you people, just tell me the number of interactions you think that 1 energy is only possible, 2 energies are possible, 3 energies are possible, 4 energies are possible in this. What is your answer according to you? Then I'll tell you then. All of you should respond at least in this. Either write me in the chat box or directly say. Okay, Wafia has answered. What about others? Rifat, Samia 4. Okay. Wafia also said 4, fine. Samia, Wafia. And Rifat and Fahad? Rifat 4, Fahad 4. Okay. See, first interaction, first energy, you people must be telling about these, no? Plus Q and 2Q. This is the first one. Then 2Q and minus Q are also exerting energy second. Minus 2Q minus Q are also exerting third, and minus 2Q and plus Q are exerting fourth. Apart from this, what did I tell you? All the interactions possible. See, aren't these diagonals also interacting? Won't they exert force on each other? Yes or no? Yes, no? So this will be fifth energy over here and a sixth energy. So 6 energies are possible. Is it clear? Why not 4? 4 are there, but most of the students miss out these diagonals and lose their marks because you won't get the correct answer. Okay. Now we have to calculate all the energies. But before that, see, separation between all these 4 energies we know, but separation between the diagonals we don't know. But when we were calculating the potential question, no, remember? Potential energy of the system at the center and whatnot. Then we had seen this came out to be what? This is root 2a. This side is AC. This side is A. This side is A. What will be the diagonal? Let's say this is A, this is B, this is C, this is D. So diagonal AC will be what? Under root 2, exactly. A square plus A square, which is root 2A. So this separation is root 2A and this separation is also root 2A. Now we'll be able to calculate the energies freely. All right, so potential energy of the system or work done of the system, both are same. Again, reminding whoever has forgotten, general formula becomes KQ1 Q2 divided by R. So first, let me tell you, Q is the charge and 2Q is the charge. I'm calculating U1. So I'll write K Q multiplied by 2Q divided by A. This is the first energy that I'm getting. Plus. Fahad, can you tell me Q2, U2? So yes, 2 charges only come in one formula. Exactly. You take the sum of other charges, that's a different, that gives you total. But firstly, only 2 charges come. Why only 2 charges? Because we are just considering this energy. Now I'm asking you, Fahad, this energy. You too. So tell me what will be the value of it. Any answer, Fahad? No idea, Fahad. See, 2 charges are there, plus 2Q is there, minus Q is there. What is the separation between them? K, Q multiplied by minus 2Q divided by root 2. No, Fahad. Root 2, why root 2? These 2 charges, this charge, UB and UC, it will be K. And what is this charge? Both these 2 charges. Fahad, tell again. From where? Root 2. Separation between both of these is A. K, first charge is 2Q, second charge is minus Q, and their separation is what? Separation is small a. Yes, so A will come. Yes, A will come. All right. Okay, so U2 is done. Similarly, we have U3. U3 will be what? K, charge is minus Q, other charge is minus 2Q, and I've told you always write the signs in case of potential energy. Like in case of Coulomb's law, we used to write the magnitude because it was a vector quantity. Right now, we are only considering with the signs also. And separation between them is A. Rifat, please try the fourth one, this.
K minus 2Q
Minus 2Q
plus 2Q
plus Q.
is plus Q.
Plus Q divided by A. Perfect. Good. So this is still here. K into minus 2Q into Q divided by A. Yes, Vahat. Right. Now we are left with the four energies are done. Now we are left with the two energies, diagonals one between AC and between B and D. So who can try? Samya, can you try?
K plus Q into minus Q upon root 2A.
Yes, right. K Q into minus Q divided by root 2A. Right. And Wafia, can you try the last diagonal which is left? BD?
Yes. K into
Hmm?
minus 2Q into plus 2Q by root 2A.
Very well said. Yes, right. K into minus 2Q into plus 2Q divided by root 2A. And this is your answer only. That's how you solve if you have multiple charges, n number of point charges interacting. Now we can easily solve this. Now this is not a tough task to solve. Just writing, it doesn't even take time to actually solve it because we are discussing now each one of you is answering, then someone is taking time, someone is typing. So that's why it takes time. Otherwise, potential energy is not such a tough topic because you don't need to consider all the directions. Where you have electric forces, electric fields, those kind of charges, those involve your much calculation because you have to keep in mind the unit vectors, you have to write all the directions, magnitude, apply parallelograms law. In case of potential, at least you can solve it freehandly. So let's solve it. KQ square by A can be taken common from all of it. Here it will be left 2. It will be minus 2. KQ square by A is common, no? So it will be plus 2. From here, what do we have? Minus 2 will be left. Minus 2. From here, what do we have? Minus 1 by root 2 will be left. Minus 1 by root 2. From here, we have minus 4 by root 2. Okay. This much is left. 2 2's gets cancelled. This becomes minus 5 by root 2. What's the answer that is coming? The final answer that is coming is minus 5KQ square by root 2A. Because this portion becomes minus 5 by root 2, no? That's how. So this is your answer. This much joules is your answer. All right, note this down. So potential energy between 2-point charges is clear. Potential energy for a single charge is not possible. That is 0. 2-point charges we have studied. N-point charges are there. One special case that is left, and that will be the last topic for today. I hope you people have written it. If anybody is writing, can text me. I'll scroll up. Potential energy of dipole. Potential energy. You have potential energy of dipole. So we'll discuss the derivation of it. Numericals are very easy. Numericals you have been handling. See how the derivation is easy. 2 charges we did it. No, 2 charges, Fahad, this. This is the derivation for potential energy between 2 charges. So write down, all of you write down the heading. Potential energy of 2-point charges. This is only K Q1 Q2 by R, no? Which we have derived. For one charge is 0, we have written W1 is 0. For 2 charges, this is the derivation. Derivation comes in your exam. So we'll keep this in mind. And n number of charges is this one. And for dipole, we'll see. Clear? I hope there's no confusion between whatever we have studied. Let's see, electric field is in this way. A dipole has been kept. P dipole has been kept with angle theta. Now, do you people remember in the previous chapter we have done the formula of torque in terms of electric field and dipole?
Yes, ma'am.
Samya, say, what is the formula of torque?
P into E sine theta.
Yes, right. Exactly. Torque was P cross E. This was torque, which is written as PE sine theta. All right. Now, what will happen? The restoring torque will try to align the dipole in with parallel to the electric field, both in this way. This is your electric field and this is your dipole. Here your dipole is right now in this way. It will try to align it. So which is this direction? This direction is right now clockwise. So torque external. Now work done external. Work done, if you people remember, it was force, integral of force and displacement. So here in case of rotational analog, it will be torque external dot d theta from theta 1 to theta 2. You people can relate it to work done is equal to force into displacement. So work done in case of rotation, because it is rotating, dipole is rotating, it will be torque multiplied by angular displacement. Now value of torque external can be written directly. Work done by external will be what? This is PE sine theta d theta, integrating it from theta 1 to theta 2. Theta 1 is one direction which we have taken. Theta 2 is some another direction in which the dipole is revolving. All right. So this is P sine theta d theta, and just we have to integrate this. So what will it be? Work done. This will be PE will be common. Integral of sine theta gives us minus cos theta. Minus cos theta from where? From theta 1 to theta 2. So this becomes PE minus PE cos theta 2 minus theta 1. This is the formula of work done, minus PE cos theta 2 minus cos theta 1. Now, potential energy, all the work done gets stored in the form of potential energy. So the formula of potential energy is also this, PE cos theta 2 minus, not theta 1, just a second, cos theta. will be cos theta 1. So the formula of potential energy will be the same. Just in case if your second theta is not given to you, it means your the angle would have been 0. That's why it is not mentioned, because cos theta will simply be 0. So u1, this becomes 0. So what is left now? Theta 2 is left. So that becomes minus PE cos theta only. This is used, minus PE cos theta. Now, questions. How do questions can come? Questions can come in three forms. This is not so tough. If you have understood the previous question, that square question, then you will be able to manage questions on potential energy. It can give you a triangle and 3 charges are kept. It can give you a pentagon and 3 charges are kept. 2 charges, straight line is kept. So square is kept. Any can form. It delete 1 charge from the corner of a square, any form. So the toughest part we have studied. Maximum it can go till here only. Now if your dipole and electric field both are parallel, this is the direction of dipole and electric field. So theta becomes what? 0. So potential energy becomes minus PE cos 0 degree. That is minus PE. Remember, potential energy coming out negative shows what? Says stable equilibrium. Bounded, unbounded we discussed. Stable equilibrium. So this is the minimum value. These little questions can come in your 1 marker theory questions. Now, if your dipole and electric field are antiparallel, this is electric field, this is dipole. Yes, this same was in the last chapter when we were discussing torque is equal to PE sine theta. Exactly, same thing, path, same. And the last case will be perpendicular, same case. Here theta becomes what? So Fahad, what will be the angle now in the second case? Fahad will answer. 180 degree, good. This will be 180 degrees. So this becomes minus PE cos 180 degrees. Cos 180 degrees minus 1. So minus minus becomes plus PE. This is the maximum value. And your system right now, this becomes your unstable system. Unstable equilibrium. That's why bounded, unbounded systems come, because of this formula. Last case is if your dipole is kept perpendicular to your electric field. Theta is 90 degree, u becomes 0. Why? Because cos 90 is 0. These are the 3 cases that can come maximum. All right, so that brings us end to the half of this chapter, that is potential. Note down this. Any doubt in this, ask me. Fahad, you take the recording of the previous lecture, if possible, if it's possible for you to watch it. Just see and be clear, because equipotential surface we discussed. And what did we discuss? One more topic, relation between electric field and potential. So see that. And then we people will be having our class on Monday from 11 a.m. onwards. This is KSA timing. Just note it down at the end when I'll reach. No, when you people have written everything, just text me done once. One more thing to you, Rifat. You were there in the last test, no? So you have scored full marks. I'll show your paper if you wish, but everything was fine. You've scored full marks. Yes, Fad. We just have to remember the formula, all the three formula for all the three cases, and basically this formula minus PE cos theta 2 minus cos theta 1. If it gives you the value of dipole, the value of electric field, if you wish, in the next class we'll discuss a numerical on it. But basically these only come in your exams. So if you remember this formula, you can easily put in the values. What about others? Have you people also completed? As you people complete, no, just text me done. So I'll know. Okay, Rifat, Samia. What about Wafia, you? Wafia is also done. Fahad, done? All right. So fine, I'm stopping